Hi student, welcome back again. Here is our second problem. And for this problem, let's read the problem. It says find the location and value of absolute extrema if they exist for the function f of s equals to 3s to the fourth minus 4s to the third minus 12s plus 2. Again, when you look at this right here, you notice that compared to problem number 1, where we have a certain defined interval, you look at problem number 2, and it does not define to you where the interval or the domains are. In this case, what they actually asking for is you need to find every absolute extrema for this function from negative infinity to positive infinity. Okay, so that means that in order to find the extrema, your first step is to find critical numbers. Critical numbers include the derivative when being 0 and also the endpoint. But because the domain is going from negative infinity to positive infinity, we are not looking at the endpoint at this time. Okay, so to start with the solution. Okay, we will be looking for critical numbers. Okay, and the critical numbers is looking by taking the derivative of this. So again, to save time, I will write down the general derivative of this, which is going to be 4 times 3 is 12s to the third, minus 3 times 4 is 12s squared, minus 2 times 12 is negative 24s, and then 0. Okay, and then we need to set that equal to 0 and solve. Okay, the LCD for this one is not LCD, the greater common factor. Greater common factor for this one is going to be 12s. Okay, so when we take that out, we have s squared minus s minus 2, and let's solve for that. So either 12s equal to 0, or we have s squared minus s minus 2 equal to 0. So in this case, we have s equal to 0. And in this case, if we do the factoring out, we are going to have s plus 1 and s minus 2. That means s is negative 1 or positive 2. Okay, so these are the three values are what we call critical numbers. Okay, the critical numbers right here. Okay, so since we do not have endpoints, okay, we will now go ahead and set a table. And we're going to make a table of s value that we found. And we're going to evaluate it on the function. So we have 0, negative 1, and 2. When we plug it into the value, negative 1 is going to give me, 0 is going to give me 2. And negative 1 is negative 3. And 2 is going to be negative 30. Well, when you look at these, you seem to see that, the 2 is going to be the absolute maximum because it's the highest value, and the negative 30 is going to be absolute minimum because it's the lowest value. But here's the problem. The problem is you have to go back and look at the function here. Okay, pay attention to this function. First of all, the highest exponent is 4. That means the end behavior is going to be either open up both ways, or it's going to be open down both ways. Okay, you remember that from Math 120? Well, then, no matter what the behavior is, it's going to be open up both ways if you have a positive coefficient here. Okay, so in this case, it's going to have a positive coefficient here. That means we are going to fall into this situation. Okay, look at that. We fall into the situation meaning that we're not going to have the absolute maximum because it's going to go to infinity. So that means we will not have absolute maximum. We will have local or relative maximum, but we do have an absolute minimum. Okay, so therefore you cannot say that this is the absolute maximum. Okay, you can only determine that we do have an absolute minimum. Okay, so then the answer to this one is that the location and the value for the absolute extrema is going to be at 2, -30 for the entire function. Okay, now I have a question then for you. That I think I kind of answered it already, is that why don't we have absolute maximum? Well, you should always go back and consider the behavior of the original function itself, okay? All right, we will go to problem number 3 in a moment.